Hey, it's me, Steve. You can see the date and time down there, but I just want to show you this. I've been working on this for a while. This is a 2-scale cross section for every one. For this segment here, A to A prime. So basically from where Ontario meets Hudson Bay at its northern tip down to the Atlantic Ocean in Georgia. Now, like I said, I've been working on this for a while. These are the units that I've come up with as of now. Now sorry, give me a second here. Sorry, I'm doing this by hand. I'm going to do this so it doesn't kick back over to the right. Here's the units that I have divided out that will appear in the cross section. This will be in full color, and like I said, this is 2-scale. This is done in Publisher, and the actual, if memory serves, yeah, here's the dimensions down here. That's how big this thing is. And being as large as it is in such a large segment, I had to take the curvature of the Earth into account when doing this. So I'm just going to quickly, I said there are changes I need to make here. This is not the final draft at all. There are some errors in it, but I just want to show you. So here's our A. That's where it is. And basically it shows you, starting there, this is the crust. This is the moho. So this is continental crust. This is all continental crust. And this would be the lithospheric mantle below. There's nothing, the cross-section isn't big enough to go deeper than the lithospheric mantle. So here we go, the units. Here we go. 1 inch is about 19.29 miles, so 19.3 miles. And this is at 100% zoom. There's Lake Superior. This is the Mid-Continental Rift area. Let's see. Niagara Fault. It's Continental Suture. Keep going. Here's the Wisconsin-Illinois border. Oh, just real quick, as I zoom in, just want to show you something. So this is 200%. Yeah, looks pretty flat, doesn't it? And that's what happens when you zoom in really small. But anyway, okay, let's see. Then we have the Sandwich Fault Zone. It's questionable things. And now the only data we really have, I mean, we have cores and stuff, but the crust is so thick compared to how deep we've been. This is at 100% again. And a lot of the subsurface stuff we only know from seismic reflection, and so on occasion you'll see a question mark like that. And this area is interesting because this is not known from any drilling data at all. This is all seismic reflection. This is the southeast side of Illinois. This would be the Centrella Basin. So we have Paleozoic sediments, and you see how thin they are, but they're really thick. They're like 15 to 18,000 feet thick at their thickest, and they barely even show up on here. There's no glacial deposits on here at all. They're way too thin to show up. But this might be a type, Yellowstone type Precambrian caldera, kind of like the in southeast Missouri with the St. Francis Mountains, which is exposed at the surface there, but here it is not. There's the Ohio Wabash Rivers. Over here we have the Reelfoot Rift, and how its present configuration is. That's an error. That's one of the things I have to get rid of. So now we're in Tennessee here. I'm going to pull this down a little bit. And I can't believe I actually measured everything and got it correct to scale. I was really worried about that. But everything seems to work out. The scale seems to be perfect. Obviously, you're not going to see much topography. I mean, yeah, here we're entering Georgia. We've got the tail end of the Appalachians, and we've got lots of deformation. But you're not going to see it here. I mean, this line is, probably represents at least a mile in thickness, and there aren't very many places this cross-section goes that are more than 5,300 feet above sea level. So even though there are mountains here and stuff, and at our scale they look huge, at this scale they don't even show up. So now we are entering Georgia, Piedmont, and now we're getting into the coastal plain. With all the Mesozoic and Cenozoic sediments on top, and those get really thick. And this would be the mouth of the St. Mary's River at the Atlantic Ocean, and this would be where the continents split. You would have, during the Paleozoic, Mesozoic, you would have these rift volcanics and sediments over here. But anyway, I just thought I'd just show you that real quick, and I can't wait to show everyone the actual real model once it's complete. That's it. Have a good day.